Alright, let's dive into the load versus fuel burn curve, specifically focusing on D8 and D15, and exploring how three different pump loads affect fuel consumption, looking at LH logs and optimal throttle settings. This is crucial for understanding engine efficiency. First, what exactly is a load versus fuel burn curve? Simply put, it's a graph that illustrates the relationship between an engine's load, how hard it's working and how much fuel it burns. It's a critical tool for optimizing engine performance and minimizing fuel use. Different engine operating conditions result in various fuel consumptions. Understanding this is important to maintain the system's efficiency. We'll be examining this concept using data from D8 and D15. These likely represent specific engine operating conditions, perhaps different speeds or altitudes. Each point on the curve gives a specific fuel burn rate. The curve is usually generated by systematically varying engine load and measuring the corresponding fuel flow in liters per hour (LH). The data will be in logs, providing a detailed record of the engine's performance. Now, let's talk about pump loads. In this context, we're looking at three different pump loads. These loads represent different demands placed on the engine's fuel system. Varying the pump load influences the pressure and flow of fuel to the engine, directly impacting fuel consumption. Different pump loads can be considered as another variable to change engine operation parameters. The challenge is to find the optimal throttle. The throttle controls the amount of air entering the engine, which directly affects the power output and fuel consumption. The goal is to find the throttle position that provides the best balance between power and fuel efficiency for a given load. Using the load versus fuel burn curve helps us to pinpoint those optimal settings. We'll be referring to LH logs. These logs provide the essential data, specifically the fuel flow rate in liters per hour. These logs record a lot of parameters, including engine speed, throttle position, and other relevant data points that will help us accurately map the load versus fuel burn curve. Analyzing the data will enable us to determine the fuel burn rate under various conditions. To create this curve, we would follow a systematic approach. First, we'd set a specific pump load. Then, we'd vary the throttle position, recording the engine's load and corresponding fuel burn rate from the logs. We'd repeat this process for each of the three pump loads. The resulting data points would then be plotted on a graph, creating the load versus fuel burn curve. The graph would show the fuel burn rate at different load levels for each pump configuration. This will enable us to determine which combination of parameters leads to the best fuel economy. In summary, the load versus fuel burn curve is essential for optimizing engine efficiency. By analyzing data from D8 and D15 with three different pump loads and looking at LH logs, we can determine the optimal throttle settings. This information enables us to reduce fuel consumption and maximize engine performance.